Let's take a look at 1.1 here. Okay, so we're in Math 9, 1.1. And we're talking about square roots of perfect squares. We did a little review and preview video about some grade 8 stuff. We talked a lot about perfect square numbers and even square roots a bit. So we're going to dig a little bit deeper into this now in section 1.1. All right, some fractions and decimals can also be perfect squares. So we talked about perfect square numbers. Those are easy, like 1 and 4 and 9, 16, 25, and all that. So those are easy to recognize, but also fractions can be. And we said something like this: 4 over 9 is a perfect square because it can be written as a multiplication of two fractions that are identical. So 4 over 9 is 2/3 times 2/3, or 2 squared times 3 squared, or divided by 3 squared. Okay, so let's take a look at this first diagram that you have on your notes package there. Okay, so if we can represent the area using squares, then it's a perfect square. So we'll take a look at graphically or visually to see how this works. If someone wants to turn those lights off in the back, you might be able to see this a bit better because there's a shaded yellow region there that you might not be able to see at the back. Okay, is that okay for everybody? Not too dark? You're not going to fall asleep on me now? Now the lights are off, lullabies are playing in your head, and now you're going to sleep? No? Okay. All right, each square below has been divided into 100 equal parts. Answer the following questions. All right, so what is the area of one small square? What would your answer to that be? One of those little small squares. What's the area of one little small square?
1 squared.
1 squared? Okay. If this is 10 units, each little square has a side length of 1. And so if it's 1 times 1 for one of these little squares, so I'll write the little 1 there, a little 1 there. So the area of this little square would be length times width, or the side times itself, which is 1 times 1, which is 1 unit squared. Very good. 1 unit squared. Okay. Excellent. Okay. What about over here on the right? What's the area of one small square here? Now remember, this distance right here is actually just 1 unit now. It's not 10, it's 1. So what is the length or the width or whatever of one of these little small squares now?
0.5 units squared.
Okay, so what's the dimension of one of these squares? What's this width? How many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is 1/10. Okay, so this is 0.1, and this side length is 0.1 as well. So if I zoom in there, we have 0.1 by 0.1. A little messy, I'll go on this side. 0.1, 0.1. So what's the area of one small square there? Well, it's 0.1 squared. What's that? 0.1. Okay, is it 0.1 or 0.01? Or two different answers. So let's turn it into a decimal. 1/10 times 1/10. That's 1/100th, right? So 0.1 or 0.1, I usually say 0.1. 0.1 times 1 is 0.1, but 0.1 times 0.1, you're taking a tenth of a tenth. That actually turns out to be 100th. So that's 100 units, 0.01 units squared, or 1/100th. All right. Okay, let's focus on this left column here now. So for the shaded area, what's the area of this shaded area? Well, this is going to be 9 units by 9 units. Okay, so how many squares would there be? 9 squares
81.
by 9 squares. Yeah, it looks like 81 units. So that's going to be 9 units times 9 units equals 81. Now we can abbreviate units squared by just u squared. Okay? U squared. And do we have to put units here? I want you to get into the habit of putting units squared. So a lot of questions will be, they won't have units given, so just u squared is going to be perfect. The reason why I want you to do that is because a lot of times in math, students forget to put their units. There's so many students that forget units. They just put the numbers and no units. It's not good. We have to remember to put units. So with an area like this, we have to put units squared, okay? Okay, so what is the area as a product? Well, I guess we kind of already did that, right? The area as a product would be 9 units times 9 units equals 81 units squared. So the product would be 9 times 9. How can you use the square root to relate the side length and area? Okay, so we have square root of something equals something else. What numbers am I going to put in there? We did a lot of work on this yesterday, right? How can I make a square root type equation here with this information? What do you think? What goes under here? So the square root of 81 then is going to be 9, okay? So that means the square root of the area equals the side length of the square. Very important. Square root of the area equals the side length. All right. I think it's going to get a little tricky with decimals. What do you guys think? Let's talk about the decimals here. Okay. Well, using the same reasoning, the very same reasoning, what's the area? What's the area of this little square of this big larger square? I guess for the shaded area.
0.9.
Sorry.
0.9.
0.9. Okay, 0.9. How did you get 0.9 or 0.9?
Because it's 1, take away 1. So
Okay, 1, take away 1/10. Okay, so you went for the larger square, and you took away 1/10. Okay, let's see. If I have each one of these squares is 0.01 units squared, so that's this one here, this one also, this one, this one, this one, this one, this one. How many actually squares do I have here? Like actual squares. I have 81 squares. Okay, so I have 81 shaded yellow squares here. And each square is 0.01 units squared. So would it make sense that I say 81 times 0.01? Do you like that or no?
No.
You don't like that? Okay, why not?
Something's off about it.
Something seems off there? Okay, well, how many white squares do I have that are not shaded? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So I've got 100 squares here minus 19 squares. That is 81, isn't it?
Yeah.
Okay. So what's 19 times 0.01? Well, that's going to be 0.19, right? 0.19. Okay, so that's what I don't have out of this. So what is 1 minus 0.19? Because that's the yellow stuff that I have left.
0.81.
0.81. Okay? So I actually have, if you're talking about this yellow square here, I actually have, and I'll highlight this yellow, I guess. I have the side length of 0.9 times another side length of 0.9. So another way to look at this, area as a product, I'm going to do this way. 0.9, that's a side length, times 0.9. And that is 0.81. So units squared, and of course we'll do units squared here. Okay, what do you guys think about that? Does that clear things up for everyone? Okay, and see why it's not 0.9? It's 0.9 times 0.9. That would be the area. So the side length is 0.9, but the area is not. Okay, another way to look at this would be in fraction form. I guess we have 81 times 1 out of 100. So that's 81 out of 100, or 81 100ths units squared. That's another way to look at that, which is exactly what this decimal is. Okay, so here's the whole point of this. How can we use a square root to relate the side length and area? So the square root of what equals what? Okay, the square root of 0.81 is 0. What? Right here, 0.9. Okay? Yeah.
I have a question.
Yeah.
For the top where we were like finding the area, why didn't we just take like one square?
All right, so let's move on to the next page here. The next page says, some of the questions on this page, again, we're trying to figure out how to work with fractions here, okay? So to determine the area of a square, we multiply the side length by itself, okay? We know that. In this example, we've got a large square, and there are 15 tenth units here, okay? So this length is 15 over 10, let's just say. In order to find the area, what we do is we multiply the side length by itself. So 15 over 10 times 15 over 10 is 225 over 100. Now that is the area. It's not necessarily simplified though, is it?
No.
Can we simplify 225 over 100? Like we could divide it, both the top and the bottom, by what? 20, okay, by 25?
Yeah.
What do I get when I multiply or divide these by 25? 9 over 4. Okay, excellent. Excellent. So does that look like its simplest form? No? Well, it is simplest form because we can't divide
9 by 4.
we can't divide 9 and 4 by the same whole number to reduce that fraction. So I think maybe what you're looking at is you're saying, hey, those are both perfect squares, which they are, which is actually going to be important for us to notice as well. But anyways, we'll talk about that later. Okay. All right. What about this next one? To determine the side length, if I know the area, I take the square root. Now, in a fraction form, it might be a little bit easier to see how to do that. So root 169 over 100. What you want to do is you want to find a fraction that multiplies by itself to give this number. Or what is the square root of 169 and what is the square root of 100? So that's another way of looking at how to do this question. So they show you here that, hey, if you multiply 13 over 10 times itself, you'll get 169 over 100. Therefore, your square root is 13 over 10. Here's another way to look at it. The square root of 169 is 13. The square root of 100 is 10. So I like this way as well, okay? And really that's what they're doing here to split this up. They said, hey, what's the square root of 169? 13. What's the square root of 100? It's 10. So the side length here are 13 over 10 units. 13 over 10 units. It's just curiosity here. 1, 2, 3, 4, 5, 8, 9, 10, 11, 12, 13. Look at that. So each of these are 10th units. There's 13 10th units here by 13 over 10 units. So there should be 169 total in here. And there are. Okay. Use a diagram. So this next question, use a diagram to determine the value of the square root of 9 over 25. The square root of 9 over 25. Okay. So there's 9 25ths, 9 25ths, and that's going to be the area, right? Underneath the root sign, this is going to be the area of some square. So if I put, first of all, we're dealing with 25ths. So here's how you would do this. Just like we did with the first couple questions, make a big square. And then I want to make these into 25ths. So guess what? I got to slice this into 5 sections by 5 sections. We're going to make 25ths first. 1, 2, 3, 4. These might not be very even. 5. And then, actually, you know, you can do this. There's one in the middle. One line goes in the middle. And then there should be 2 more on this side, evenly spaced. 1, 2, 3. Wait a minute. 1, 2, 3, 4, 5, 6. Wow. Okay. Let's start that again, Mr. Maxwell. 25. There you go. There you go. So I just need 4 vertical lines. 1, 2, 3, 4. We're making 25. So 1, 2, 3, 4, 5 sections. Same thing over here. 4 horizontal lines. 1, 2, 3, 4. There we go. Now I've got 25. Thank you very much. You're welcome. Okay, now I need to highlight 9 of these. And if I can make a perfect square with 9 of them, that would be best. So don't do like a maze, like, oh, what happened there? Don't do like a maze, you know, like, oh, I'm going to connect all these dots together here for this one. Oops. So what you want to do is you want to say, okay, how can I just highlight 9 of these? You're going to go like something like this. There's 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay? And notice how I can actually make a perfect square out of those 9. So what is the value of the square root of 9 over 25? The key is right here. The side lengths of this square. So we make a square, and then what's the length of the sides here? They're 3 something. 3 what?
3 square.
Now 3 25ths? Or something else? Okay, look at this. There's actually 1, 2, 3, 4, 5 along the side. So if we're talking about side length, that's 3 fifths. And this one is also 3 fifths. So the square root of 9 over 25 is 3 over 5. And now you're not going to have to do a diagram very often here, okay? You're not going to have to draw that every time for sure. Because we want to actually get to the space where, hey, square root of 9 over 25. Well, what's the square root of 9 and what's the square root of 25? And if those are perfect squares, then this is a perfect square number. And that's what we're getting to. Okay, so you could think about it like that. So the areas under the root sign, the value of the root would be the side length of the square. All right. So knowing that, let's move to our next question, which says, example 1 on page 8 here. Let me make these a little bit bigger for you. So to determine if a fraction is a perfect square, are you ready for this? This is important. We need to find out if the numerator, that's the top number, and the denominator, or the bottom number, are both perfect squares after simplifying. So are they both perfect squares after simplifying the fraction? If we can say yes, then we have a fraction that's a perfect square. Okay, so it has to kind of get down, as you've seen, it has to kind of get down to top number is a perfect square on its own, and the bottom number is a perfect square on its own. So this one says, is 4 over 9 a perfect square? Well, can we simplify 4 over 9 anymore? No. So is it a perfect square? Yes, it is. Why? Because 4 is a perfect square, and 9 is a perfect square. And so the square root of 4 over 9, we already took a look at this maybe once, I think, is what?
2 over 3.
Very good, 2 over 3. Okay, now this is different than simplifying fractions, right? We're not dividing the top and the bottom by the same number. No, we're taking the square root of the top and the square root of the bottom. Okay, very good. Let's take a look at example 2. Is 16 and 4 ninths a perfect square? 16 and 4 ninths. Now, what we want to do is we want to change this mixed fraction into an improper fraction. Okay, because there really is no top and bottom because we have this number on the side right now. So don't be fooled by this. What we'll have to do is we'll have to go 16 times 9 plus 4 over 9. So what's 16 times 9? Well, let's see, 9 times 10 is 90, 9 times 6 is 54. So is that 144?
Yeah.
1 plus 4 is 148 over 9. So that's what this is as a mixed fraction into a improper fraction. So 9 times 16 plus 4 all over 9. Okay. Now, can we simplify this anymore? Like this fraction on its own, can we divide both by, well, 9 only divides evenly by 3. 1, 3, and 9. So we won't forget about the 1. So 3 and 9, can we divide 148 by 3 or by 9 evenly? Don't think so. You can check on your calculator too if you want. Just do 148 divided by 3. See if you get a whole number or a decimal. If you get a decimal, then it's not evenly divided by 3. Do 148 divided by 9, for example. If it's a decimal, whatever, then it's not going to work. So I'll just show you. 148 divided by 3, let's say. Oh, we get a decimal. 148 divided by 9. Oh, we get a decimal. So you cannot simplify this anymore. So let's check. Root 148. Is that a perfect square?
No.
I know 9 is. That's a perfect square. But root 148, is that on our list? Okay, some of you are saying no here. Let's just check it out. Square root of 148. Ah, it's a decimal. So when we're taking the square root of a whole number like that, and the answer is a decimal, or you know, something like that, then that means it's not a perfect square, right? So this is about 12 something, 12.16.1655 approximately. So is this a perfect square? No, it's not. Not a perfect square. Because when simplified, the top and the bottom are not both perfect squares. Okay, let's do example 3. Example 3, 4 times 25 is 100, so that's 121 over 25. What I want to do is I want to see, can I reduce this any? Well, no, I don't think so. But what else? What do you see right away? Anybody see anything right away?
Squares.
Yeah, root 121 and root 25 are both, the answers are both whole numbers, so that's great. What's the root 121? 11, good. And root 25 is 5. There you go. So is it a perfect square? Yes. And this is the square root. So root 121 over 25 is equal to 11 over 5. And please remember to reduce your fractions wherever possible. Okay. All right, let's summarize what we found out here. Let's summarize this now. So how can we determine if a decimal is a perfect square? How can we determine that? What are some of the things that we talked about here? Well, okay, so for fractions, okay, that's what we've been dealing with mostly here. Let's do fractions. We've got some rules for fractions. So we want to simplify the fraction. Simplify the fraction. Simplify first. Then we want to check to see if both the numerator and the denominator are perfect squares. Okay? Check both numerator, that's the number on top, and denominator, that's the number on the bottom, are perfect square numbers. And if that's true, then yes, it's a perfect square. Okay? Then yes. And if this does not happen, then it's a no. All right, 1.44. Let's see if this is a perfect square. Root 1.44. So if I change this to this decimal into a fraction, remember we did that yesterday? I would have what? And we'll talk about decimals in a bit. But this is, what's this as a fraction? Okay, so the number is 144. And the last place that the last 4 takes up is the 100th spot. So that's 144 over 100. Now notice that 144 is greater than 100, therefore that decimal should be greater than 1, and it is. Okay? So it's an improper fraction here. All right, so if I take a look at this, is 144 a perfect square?
Yes.
Yes, it is, and that square root is 12. Oh, and this is 10. Now, I didn't simplify first, did I?
No.
I noticed right away that these were perfect squares. So if you notice that they're perfect squares right away, you can actually take the square root right away and then simplify. So watch this. What's this going to be? 6 over 5? Okay. Now, I just broke my rule, right? Simplify first. But if you see that they're perfect squares, you can take the square roots first. But let's follow the rules and simplify first. See if it still works. So 144 over 100. Can we simplify this? Yeah, we can divide both by 2, for sure. That's, what, 72 over 50.
Yeah.
Can I divide both of those by 2 again? Yeah, that's actually 36 over 25. So, just like multiplying fractions, if you simplify first, it might be a little bit easier, because this is now really easy to find out. The square root of 36 is 6. The square root of 25 is 5. Get the same answer. So it's either you simplify first Or if they're perfect squares, you can simplify second. That's okay too. All right? Okay. So this has a decimal, interestingly enough, this is a decimal is 1.2. 1.44, 1.2. Interesting, hey? Okay. All right, let's do example 2. And again, let's take a look at our decimal method. So 6.4, that's 64 over what? Over 10. Yeah, that's 64 over 10. So 64 divided by 10 is 6.4. We have the number 64. And the last digit occupies the tenths spot. So we'll do 64 over 10. Now let's simplify this. So I'm going to go 32 over 5. Can I divide that any further? I don't think so. So is 32 a perfect square?
No.
Is 5 a perfect square? No. So this is not a perfect square. What about this one? This is 64 over 100. Is 64 a perfect square?
Yes.
Ooh, it is. That's 8. Is 100 a perfect square? Yeah, that's 10. So, we could have simplified this first again, but I noticed that they were perfect squares. So that's 4 over 5, right? So that's one way of doing it. Like I said, if you simplify first, let's do that. We can divide both by 2. We can divide both by more than 2. So here's 2, 32 over 50. I can divide these by what? 2 again, which is 16 over, oh, there we go. Perfect squares again. Root 16 is 4, root 25 is 5. Okay? Now, this will take a little bit of time for you to get comfortable with, I know, because it did for me too. So finding the square root of decimals and knowing which are perfect squares, if you change it to a fraction, it's easy to see, but I want you to try and get to learn this chart that's in your notes, okay? So 0.1 squared is 0.01. We talked about that one already. Notice that the numbers 1, 2, 3, 4, 5 are related to their perfect squares, 1, 4, 9, 16. It's just that the decimals are a little bit weird, right? So a couple ways you can think about this. 0.4 times 0.4. Remember how you used to do this in elementary school? 4 times 4 is 16. 4 times 0 is 0. Carry the 1. 0 times 4, 0. 6, 1. Now what do you do with these decimals? Do you remember what you used to do? Yeah, okay. Count how many numbers are behind the decimals, or how many decimal places we have. Like, so from a regular number, we went back 1, and then we went back 1 here. So we go back 2. 1, 2, and there we go. There's our answer, 0.16. So 2 decimal places here. You got to go back 2 decimal places in your final number, or 2 numbers behind the decimal, 2 numbers behind the decimal. So that's this one. Okay, right there. Now 1.4 squared, here's another thing for you to think of. Let's go 1.5, because you know what 15 squared is, or maybe you do, maybe you don't. But 15 squared is 225. You might have that memorized. So if we have 1.5 squared, that's 1 decimal place. So I go 2 decimal places for my answer. See that? And one more way to think about that, if you have 1.5 and you multiply that by 1.5, I need to get just a little bit bigger, right? So you're going 1.5 times of 1.5. So that's going to be, that makes sense that it's just over 2. So 1.5 times 1.5 would be just over 2. Okay? Funny thing is here, when decimals are less than 1, like 0.7 times 0.7, the answer actually gets smaller here. These are smaller. You see that?
Yeah.
Smaller. And these numbers are a little bit larger. So when you're multiplying a number less than 1, like a decimal number, times itself, that actually gets smaller. Which, let's see if that makes sense. 0.7 of 0.7. So 7 tenths of 7 tenths. So do you see how this is less than 1? So the answer must be smaller than this one. And it's actually, 49 over 100. That's actually smaller than 0.7. 0.7 squared is 0.49. It's smaller than the original number. So there's some weird things that kind of happen there, but the more you study this and kind of get to know the squares of decimals, it'll help you. And of course, if you look at 0.16 and you take the square root of that, right, that's 0.4. So 2 decimal places, each has to be 1. Anyways, any questions about that? Okay, one final thing I want to show you before we're done this section here. The square root of a perfect square decimal. Okay, so how do we know if a decimal number is a perfect square number? Okay, you can't use your calculator to find this out, because what we're going to have to examine is if the decimal that we get as an answer when you take the square root, you have to look at 2 things. Is it terminating? Okay, so the square root of a perfect square decimal is either a terminating decimal, which means that terminate means to end, right? So if you have a decimal that ends, like for example 0.16, stop, that's a terminating decimal. 0.2478951 it doesn't seem to stop. If it fills up your entire calculator screen, it does not seem to stop. So that's not terminating. Okay? A repeating decimal. Here's the other thing you want to look for. Is the decimal repeating? So does it have the same digit that repeats every time, like 0.33333333? That's a repeating decimal. Or if there are blocks of numbers that are repeating. For example, 0.327, 327, 327, 327. That's a repeating decimal as well. Okay? And those are hints that your number, your decimal number, is a perfect square. And real quickly, like I said, the square root of 0.4 is 0. Sorry, let's do it this way. 0.16. The square root of 0.16 is 0.4. See how this decimal terminates? It stops. Okay. What about a repeating decimal? Well, check this one out. 4/9. We already know that that is a perfect square fraction, right? As a decimal, this is 0.4 repeating. Okay? 0.4 repeating. 4/9 is 0.4 repeating. 5/9 is 0.5 repeating. Okay? Okay. Okay, so let's do some of this here. So 0.169, what's the value of the square root? You can use your calculator for this. Okay, so find your square root button. Make sure you know where that is on your calculator. 1.69 is 1.3. Okay, 1.3. What type of decimal is it? Is it a repeating or a terminating decimal? Is it one of those?
That's a terminating.
It's a terminating decimal. That's correct. So is this decimal a perfect square? Is 1.69 a perfect square?
Yes.
Yes. Yes, it is. Okay. So 3.5. Let's check 3.5. Square root of 3.5 is 1.870828693. Now, how do you know that it doesn't terminate right here? Well, if it fills up your entire calculator screen with no repeating parts or anything like that, you can probably assume that it's not terminating if it fills up your entire calculator screen. How do you know that? You don't know for sure, but this is the indication. If there's no repeating parts and it fills up your entire calculator digits, then it looks like this is not a terminating decimal. Okay? So 1.8708, and it keeps going on. So it's non-terminating that we can tell, and non-repeating. So does this look like it's a perfect square? It doesn't look like it's a perfect square. No, remember, it has to be one of these two. Okay? All right. 70.5. Let's do that one real quick. Whoopsie. What did I just turn that off? Okay, square root of 70.5. It's another one, 8.39, no repeating, and it looks like it fills up the entire screen there. It looks like it's going to keep going. So 8.396 or so. Dot, dot. So again, non-terminating, non-repeating. So it looks like no. Our best guess would be no. And again, we can't see all the digits, I get it. Okay. Okay, 5.7, so, tell you what, you guys do the rest of these. You guys do the rest of these, I don't know, fill out that chart. And I'll show you what my answers are in a second. Okay, so it looks like that's what the last few rows of your chart should look like there. Let me know if you have any questions about that. You guys good with that? Okay, make sure you have a calculator, okay? I'm seeing a few of you that don't have calculators out. Make sure you have a calculator. You do need one for this chapter. Here's your assignment as well on the bottom. I think most of you wrote that down yesterday. You got maybe a little start on that yesterday, so there's your assignment. Okay, and that's your lesson on 1.1. So you have about 10, 12 minutes to work on that. I will give you some time tomorrow as well to finish your 1.1. Okay, so that's perfect squares, fractions, and decimals lesson. Any final questions?